Namaste bachcho. Myself JVN Dr. Monica Trivedi. I'm from Department of Science and Technology, Faculty of Education and Methodology, Jyoti Vidyapeeth Women's University, Jaipur. Students, today's topic is harmonic oscillator. The harmonic oscillator played a leading role in the development of quantum mechanism. In 1900, the Planck made the bold assumption that the atom act like an oscillator with quantized energy when they emitted and absorbed the radiation. In 1905, the Einstein assumed that the electromagnetic radiation acted like electromagnetic harmonic oscillators with quantized energy. In 1907, Einstein assumed that the elastic vibration of a solid behave as a system of mechanical oscillators with quantized energy. These assumptions were invoked to account for a black body radiation, the photoelectrical effect, and the temperature dependency of the specific heats of a solid. Subsequently, the quantum theory provided a fundamental description of both electromagnetic and mechanical harmonic oscillators. Now, the derivation of harmonic oscillator. Here you can see that the function and the force is given by the F is equals to minus kx, and it can also be written as mu x is equals to minus integration of f dx. Okay, now the F force is integrated, and we will get the kx dx here. So the potential energy will be for this, the potential energy will be nu x 1 by 2 kx square. Now this value will be putting on the Schrodinger equation. Okay, this is the Schrodinger equation. Minus h square by 2m del square plus mu r psi r is equals to E psi r. And if we write this equation as respect to the x, we will get minus h square 2m del square del x square. Then we have to put the value of omega from the above equation, which is 1 by 2 kx square psi x is equals to E psi x. Now if we move this function to this side, we will get the del square by del x square minus mk h square x square and psi x square. Okay, and is equals to minus 2m by h square E psi x. This is the equation 1. Now let us assume that for this the epsilon is equals to mk h square half, and which is equals to x, and if you put the epsilon square is equals to, this value will be double. Okay, here the value is epsilon square is equals to mk by h square 1 by 4 and x square. Now the del, if we see that the del and del by x, del x is equals to mk h square 1 by 2 del epsilon. Now we can put the value of del square del x square is equals to mk h square 1 by 4 del square del epsilon square. Now this, the putting this value in equation first, okay, we will get mk h square 1 by 2 del square del epsilon square minus mk h square 1 by 2 epsilon psi epsilon is equals to minus 2m h square e psi epsilon. Now we will get by about equation the m and k h square is common in about reaction, and we will get the del square del epsilon square minus epsilon square psi epsilon minus 2 m k h square 1 by 2 e psi epsilon. Now put the epsilon is equals to m k h square 1 by 2 e, and e here is 1 by m 1 by 2 k by m 1 by 2 h epsilon. The e is equals to epsilon h omega, and as we know that the delta square by delta epsilon square minus epsilon square h and epsilon is equals to minus 2 epsilon n psi n epsilon. This is the equation 2. Now, the quantum energy spectrum consists of direct values according to energy level. The psi n epsilon is the angular function for state n, and En is the energy of a state n. Okay. So the problem now is to be determine the psi n and epsilon n. To determine these function, the fractional method is used. For this, the psi and psi epsilon minus epsilon, del and del epsilon minus epsilon, and del epsilon plus epsilon is equals to del square del epsilon square minus epsilon square plus 1. This is the first equation, and the second equation will be S term minus which is del epsilon plus epsilon del epsilon minus epsilon, which is equals to del square e epsilon square minus epsilon square minus 1, which is equation second. Now applying this functionized method on equation 2, what will we get? We will get the del epsilon plus epsilon del epsilon minus epsilon del epsilon plus epsilon psi n epsilon is equals to minus 2 epsilon n plus 1 del epsilon plus epsilon psi n epsilon. This will be equation 3. Okay, now from this equation, del epsilon minus epsilon psi n epsilon is equals to 0. So its solution will be psi n epsilon e raised to power 1 by 2 epsilon square. By comparing equation 2 and 3, we will get that as we all know that epsilon n plus 1 is equals to epsilon n plus 1. Okay. And by the secondary equation, the epsilon and the del epsilon minus epsilon del epsilon plus epsilon. Okay, we will start it again. Del epsilon minus epsilon del epsilon plus epsilon del epsilon minus epsilon psi n epsilon is equals to minus 2 epsilon n 1 del epsilon minus epsilon psi n epsilon. This is equation 4. From this we will get the del epsilon plus epsilon psi n epsilon is equals to 0. So its solution will be epsilon psi n epsilon e minus 1 by 2 epsilon square. And by comparing both 2 and 4 equation, we will get epsilon n minus 1 is equals to epsilon n minus 1. Okay. So we will get the two values, the inhelimination of the reactions of these operators. We will get the del epsilon plus epsilon psi n epsilon psi n minus 1 epsilon, and del epsilon minus epsilon and psi n epsilon, psi n plus 1 epsilon. Okay, and for the last equation, En is equals to E minus 1 plus 1, En is equals to En plus 1 minus 1, En is equals to E0 plus n, but capital E is equals to EH nu, where we know that the En is equals to n plus 1 by 2 h nu, where n is 0, 1, 2, 3. This is a quantized energy of a harmonic oscillator, and these are the Eagle functions for a harmonic oscillator for n0, for n1, for n2, and for n3, for n4, and for n5. Okay, this is the three lowest energy Eagle functions for n0, 1, and 2. You can see psi 0, psi 1, and psi 2, and the nu is equals to epsilon, and here you can see the E by h nu. These are the different vibrational levels. So this is all about the harmonic oscillator. Thank you very much.